Cool chemistry. Hi, this is Austin's project.
Who sailed to sea, and he told us of his life.
Probably everyone wondered at least once, why does sugar dissolve in tea? Here we will not focus on sugar as such, but basically on a problem. Why some things dissolve and some do not.
Example of salt, ionic compounds. That's in parentheses. The same energy rule can be applied to salts. They are built of positive and negative ions, which are bound together by a force of attraction, hey Austin, of their opposite charges. If energy needed to break the ionic bonds is lower than the energy given off by an interaction of the ions with the solvent, i.e. water, the salts will dissociate and interact with the solvent and thus dissolve.
We have learned during the last few lessons that everything is made of particles and that these particles are always moving. In a solid, the particles move the least. However, in a gas, the particles move the most. Albert, take it away.
Thank you, Jen. Now, in today's weather, wrong forecast. In the right conditions, when the solid particles meet liquid particles, they can mix together to form a special mixture called a solution. This process is called dissolving. This process does not happen when any solid or liquid meet. Your glass doesn't dissolve when you put water in it, only when the right solid meets the right liquid. When they do dissolve, the solid part is called the solute, and the liquid dissolves in what is called a solvent. Take it away, Jen.
When you put some sugar in your coffee, you want the solid sugar to dissolve in the liquid coffee to give a sweet solution. If you want your sugar to dissolve quickly, you can do two things. We know that temperature can affect particles, so heating up your coffee will speed up the dissolving particles. The size of the grains of sugar that you will use also affect in which it dissolves. If you put fine castor sugar in your coffee, it will dissolve much quickly. Big sugar crystals found in posh coffee shops will dissolve much more slowly.
Intermolecular forces. Intermolecular forces is like bolded and the font is bigger, so that's the title of this paragraph. In process of dissolving, molecules of the solute are inserted into a solvent and surrounded by its molecules. In order for the process to take place, molecular bonds between molecules of the solute, i.e. sugar, have to be broken, and molecular bonds of the solvent also have to be disrupted. Both of these require energy.
When sugar dissolves in water, new bonds between sugar and water are created. During this process, energy is given off. The amount of this energy is sufficient to break bonds between molecules of sugar and between molecules of water. This example is relevant to any solute and solvent. If the bonds between solvent and solute are too strong, there is not enough energy provided while dissolving to break them. The solute will not dissolve.
An ionic solid dissolves in water because of its polar nature. Notice how water molecules become attached to the ions of a sodium chloride crystal in the process called hydration. Positively charged sodium ions attract the partial negative charge of the oxygen in water. A similar attraction occurs between negatively charged chloride ions and the hydrogen atoms, which have a partial positive charge. These interactions loosen the attractions between the ions in the crystal, dislodging them from the crystal. Additional water molecules surround the released ions, insulating them from attraction to other ions.
In the town where I was born lived a man.
When sugar dissolves into water, bonds between them form new. Starting there. What's the flow?
Cut compounds. Scene. Stop the camera.
Much more slowly. Can y'all shut up? I'm recording over here!
I don't think that was in the script.
It's okay. If it's permissible, we'll still love it.
There's so many typos in this thing. Okay, is it going? Alright. Enter Melissa.
Probably everyone wondered at least once why the sugar